Hello everyone, my name is Surbhi Mittal and today I will be presenting my paper titled Are Face Detection Models Biased? So what is bias? Let us see through an example. On searching Google images for beautiful faces, perfect faces and chubby faces, we observe that most of the faces that are returned are typically female faces. This is an example of bias. In the recent years, there has been a lot of emphasis on bias in deep learning. Multiple studies have been performed in facial recognition which showcase the biased behavior of models. However, there has been significantly less attention on face detection. While there have been a few cases in the news, such as the Twitter's face cropping algorithm, where there has been a lot of talk about bias in face detection models. The primary reason why there has been such limited research in face detection bias is a lack of databases. The benchmark datasets do not contain annotations for both demographic as well as non-demographic factors. The seminal work called Gender Shades was done using a dataset called PPB, which contained only one face image per image. Existing studies have considered face detection as a binary classification problem instead of a localization problem. So they would take an image and would classify whether this image has a face or whether it does not have a face. However, in real world scenarios, a localization setting is more useful, where you give it an image and it localizes the region which contains the face. This kind of face detectors are used for multiple pipelines like in face recognition and so on. To study bias in face detection, we propose the F2LA dataset, Fair Face Localization with Attributes, in which we provide the localization annotation, that is the bounding box annotation, and additionally provide 10 attribute annotations. The dataset consists of a total of 1200 images encompassing 1774 faces. These are some of the samples of the F2LA dataset. For the experiments, we use 4 face detectors called the MTCNN, Blaze Face, Retina Face and DSFT face detectors. All of these face detectors are fairly popular. For evaluation, we use the detection accuracy to measure the accuracy of the face detection system. The detection accuracy is computed as the ratio of correctly detected faces and the total number of faces in the set. To compute the bias in the performance, we use disparity, which is the standard deviation of the detection accuracies across the different classes. So to find out the disparity across gender, we would find the standard deviation of the detection accuracies for male and female. So are face detection models biased? Here are the bar graphs which showcase the performance of the different models across age, skin tone, for 2 different IUU thresholds. We observe that there is a disparity in performance of the different models across the different classes. Very few models perform consistently well across all the different classes. Similarly, for gender, we observe that there is a disparity in performance, with face detectors performing much worse for the male subgroup. This trend is observed consistently for all the face detectors at different IUU thresholds. So why do we observe such biased behavior? Here we study the different samples that were missed by the face detectors. We observe that there is a role of demography where MTCNN model performs badly on individuals belonging to old and male subgroup. Similar observations were made for the Blaze Face model. This can also be seen in this figure right here, where the first 2 blocks show that the models often miss older people as well as males. In other factors, we observed that empty CNN and place face models failed to detect faces on grayscale images. A lot of these samples were grayscale, which were missed. Similarly, size of the face plays an important role. The faces which were quite small with respect to the image were missed by the place face model, whereas faces which were quite big with respect to the image were missed by the retina face model. In another analysis, we studied the distribution of the wider face dataset. Empty CNN, DSFT, and retina face are all trained on the wider face dataset. The trained dataset is skewed towards typical poses and normal illumination. So what we observed is that our model, that these detectors on our dataset performed better for frontal poses, which are considered to be typical poses, and performed better under normal illumination. So therefore, we observed that the skew in the dataset was translating into the results that we were getting. To conclude, we observed that there is disparate performance in the face detectors. We also observe that there is an interplay of various factors. So it is important to study the performance of these detectors in a holistic manner. We also observe that more effort is required to study face detection in a localization setting. We believe that the proposed F2LA dataset can help in exploring these issues. Finally, we observed that some of the face detectors perform really well, such as the DSFT detector. So if the face detection becomes 100% accurate, all the bias will be automatically mitigated. Thank you.